Welcome back to the next session of number systems. Irrational numbers. As I discussed in the previous session about the concept of irrational numbers, that is a decimal expansion of irrational numbers or non-terminating and non-repeating. The given example represents the concept of irrational number, that is the decimal expansion never terminates and never repeats. Here we can see some properties of rational and irrational numbers. First one, the addition of an irrational number and a rational number gives an irrational number. For example, 2 plus root 3, which is an irrational number. Second one, the difference of an rational number and an irrational number gives an irrational number. For example, 3 minus root 2, which is an irrational number. Third one, multiplying any irrational number with any non-zero rational number results in an irrational number. For example, 3 into root 2 is equal to 3 root 2, which is an irrational number. Learn about operations on irrational numbers. First, sum of two irrational numbers need not to be irrational. Using these two examples, we will verify this condition. Take first irrational number as 2 plus root 3 and second as 4 minus root 3. While finding the sum of these two irrational numbers, we will get the result of 6, which is a rational number. The second one, take root 2 and root 3 as an irrational numbers. While finding the sum of these two irrational numbers, we are getting the result as irrational number. Hence, we can conclude that the sum of two irrational numbers may or may not be an irrational. The difference of two irrational numbers need not to be irrational. Based on this example, we will verify the condition. First, take first irrational number as 5 plus root 2 and second as 3 plus root 2. Find the difference between these two irrational numbers. While finding the difference, we are getting the result as 2, which is a rational number. The second example, consider root 2 and root 3 as an irrational numbers. Subtract root 3 and root 2. While subtracting root 3 and root 2, we are getting the result as 0.318, which is an irrational number. Hence, we can conclude that the difference of two irrational numbers may or may not be an irrational. Third, product of two irrational numbers need not to be irrational. For that, the first example to verify, for that I had given some examples to verify the statement, to verify the above statement. For that, one, quotient of two irrational numbers need not to be irrational. For that, just see these two examples. Divide an irrational number 3 root 2 by root 2, which gives a result as 3, which is a rational number. In the second one, while dividing an irrational number root 3 by root 2, which gives an answer as irrational number. Hence, we can conclude that the quotient of two irrational numbers may or may not be an irrational. Students, we came to an end of this session. A small recap, whatever we learned in this session. First, we started with irrational numbers and then properties of rational and irrational numbers. At last, operations on irrational numbers. I hope that all you understood about this concept. Based on this concept, we will learn to solve the problems in the next session. Thank you.